Right, in this video I'm going to be taking some time talking about quadratic functions and more so the solving that goes along behind it. Just talking about how do you solve quadratics by factoring using the quadratic formula as well as the square root property. This is something that you should feel very comfortable doing coming into this class, and then we will be spending more time on quadratics once we get into chapter 1, as well as talking a little bit about them once we get into our polynomial unit as well. So let's just talk about, first of all, what are the two forms of quadratics that you are likely to see? We're going to see them in the form of ax squared plus bx plus c, which is the standard form. And you are familiar with that because that form is what we use for when we're factoring things out or when we are using the quadratic formula. And then the other one here is our vertex form. Now, vertex form is going to be very helpful for us, more so in the ways of graphing something out, being able to sketch a graph of what it looks like. As far as if it's in vertex form, we also can really solve it very easily too. So vertex form is actually a really nice form for a quadratic to be in. You can always go from standard to vertex form doing completing the square method. We don't necessarily spend time doing that, but that's possible. We're going to be looking at more so just looking at our graphs and being able to put it in vertex form that way. So just kind of going back, a couple examples here of just looking at how do you solve quadratics. This is an example of where we would be able to use our square root property. And the reason I can use the square root property is because, first of all, I notice it's a quadratic because it's x squared, but there's no other bx to this problem, so I don't have that middle term, and so I don't have to worry about combining like terms or anything. In this here, we could easily go ahead and add 3 to both sides, just like you're solving an equation, a linear equation. So 7x squared is equal to 175. And then you can go ahead and divide by 7. And we're left with x squared is equal to 25. Well, to get rid of that square then, here's where our square root property comes in. We take the square of both sides of our equation. So x is equal to plus or minus 5. The important thing here is that you're remembering that there are 2 possible solutions. There are 2 numbers that when you square them, you will get 25. So it's a key thing to remember, the plus or minus. When you're factoring or when you're using a quadratic formula, the 2 answers are pretty much worked into the answer or into the problem. Here, this is something that you have to recall. As far as factoring goes, x squared plus 7x plus 12. If you're going to factor, you always have to have your function equal to 0. We use what's called the zero product property. So you're trying to undo that FOIL process. If you were in an algebra class with me or even geometry class, you know, we talked about making the box, but you are probably at a point now where you can go beyond that and you're probably able to do more of these in your head. So x squared plus 7x plus 12. I need the first 2 terms here to multiply together to be x squared, so I can do x times x. And then I'm going to be looking at the last number here, 2 numbers that are going to multiply together to give me 12. And also I need to make sure that when I FOIL this out that my middle term is 7x. So as far as that goes, we're going to go ahead and use 4 and 3. If I use a plus 4 and a plus 3, if I FOIL this, x times x is x squared, x times 3 is 3x, 4 times x is 4x. That added together gives me 7x, and then 4 times 3 is 12. So the zero product property says that, okay, we can go ahead and take our factors here and we can set each of them equal to 0. Because you're taking 2 things here and you're multiplying them to get 0, the only way you can get 0 is if you multiply something by 0. So that means that x can either, or x plus 4 can equal 0, or we can have x plus 3 equals 0. If I go ahead and I solve here, we get that x is equal to -4 and that x is equal to -3. If I were to plug these answers back in, -4 plus 4 is 0, -4 plus 3 is -1. So 0 times -1 gives me 0. Same thing with negative 3. Negative 3 plus 4 is positive 1. Negative 3 plus 3 is 0. 1 times 0 is 0. So both of those are solutions. So you definitely could factor those out. Don't be scared if you have something with a leading coefficient that's other than 1. I mean, you can still factor a problem out here. The biggest thing is that you can't look at the negative 15 and the x there. So a lot of times people say, well, there aren't any numbers that I can multiply together to get negative 15 and add to 1. So they think they can't factor this. But you've got to be careful because you've got that 2x squared. So that means that 2x times x gives you 2x squared. So now when you do the multiplying here, let's go ahead. I'm going to put a plus 3 here, and I'm going to put a negative 5 here. When I take 2x times 3, that gives me 6x right there. Negative 5 times x gives me negative 5x. Well, that is going to add up to positive 1x. So just be careful because that 2x is going to factor into the O and the I of your FOIL there. So 2x minus 5 is equal to 0. X plus 3 is equal to 0. We'll do a lot of factoring, and not even necessarily just in quadratics. We introduce it into other areas too, especially once we get into our trigonometry unit. So it is something that you want to become very comfortable doing. Here I get an answer of 5/2, and then we can subtract 3. And so x is equal to negative 3. We also talk a lot about it when we're working with our rational functions, so just kind of keeping yourself on top of all of it. Sometimes if you have a function that looks like this, you can always look at factoring out GCFs too. Especially if you are someone who likes to do the factoring, always look to see if you can take something out. Like I could divide everything here by 10, and that's just going to simplify this down for me. So 10 times the quantity of x squared plus 5x minus 24 is equal to 0. A lot easier to now factor out the x squared minus 5x minus 24. Because now I can look at two numbers that are going to multiply together to get negative 24 and add together to get 5. So 8 and negative 3. Oops, that's a 10 right here. So that 10, that GCF really doesn't do anything for us here because it's your two factors here that have to equal 0. So x plus 8 can equal 0 and x minus 3 can equal 0. So we get answers of x equals negative 8, and we get x is equal to 3. All right, so now the only thing is not every single quadratic can be factored. So we need to look at what's another option. So don't ever forget that you also have your quadratic formula. Hopefully you can remember x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And perhaps you're singing the song that you learned in algebra or geometry with me. But this is always another way to get around it. So using this, we can easily identify what our values of a, b, and c are. A is 8, b is 11, c is 2. Make sure that it's always equal to 0 in order to use your quadratic formula. So x is equal to negative 11 plus or minus the square root of 11 squared minus 4 times 8 times 2 all over 2a, so 2 times 8. If I go ahead and simplify this, I get negative 11 plus or minus the square root, and this is going to give me the square root of 57 all over 16. So I have two different answers here. I have x is equal to negative 11 plus the square root of 57 all over 16. I also have x is equal to negative 11 minus the square root of 57 all over 16. If I put those into my calculator, I would get an approximate value of negative 0.216, and here an approximate answer of negative 1.159. All right, so those are all the different ways of solving quadratics and working with those. Now I just want to remind you of a formula that's going to pop up periodically, and that's the vertical free fall motion formula. So whenever you throw something up in the air, because of gravity, it's going to come back down. And when we do this, we see a lot of this type of shape happening. And that's our parabola, and that goes along with our quadratic. So throwing something up in the air and having it come back down. So our function here is going to give you the height at a given amount of time. So I have negative 1/2 g times t squared. G is the gravity, and that can be two different numbers. It can either be 32 if you're referring to feet per second squared, or you can talk about it being 9.8 meters per second squared. T is going to be our time in seconds. V sub 0, that's our initial vertical velocity, times t here, and then plus s sub 0, which is the initial height. So this formula is going to be coming up. This is one that you're going to need to know, so we can kind of start thinking about it. Usually I try to provide it for you, but it's not always provided on some of the practice assignments and things, so you might have to look back to it. But now I'm going to take our quadratic solving that we just did here and tie it into one of our first lessons that we did, and that is working with domain and range. So you're going to see a lot of application type problems popping up, and these are the things that I really want us to be focusing in on. A lot of what we do in these first couple chapters is review from what you had in Algebra 2. Now we're going to try and go beyond that. So we're going to take what you already know and try and do a little bit more with it. All right, so here I have a word problem that says a projectile is launched up in the air from a platform of 10 feet above the ground. With an initial velocity of 100 feet per second, determine the domain and the range of the projectile. So you're thinking about this. Sometimes it would be helpful if you just even think about this on a graph. What would this possibly look like? So we're starting at 10 feet, and something's being thrown up into the air, and then it's going to come back down. All right, so if we're trying to first of all figure out, well, what is the domain and the range of this projectile? Well, domain, we talked about how that is our x values, and in our case here, this is going to be referring to as our time. We need to figure out how long was that projectile in the air for in order to talk about this solution that's here. Well, that projectile is in the air for as long as when it started to when it hit the ground. Now it started at 10 feet, and that's when t is equal to 0. Now what we're trying to do here is figure out, well, what is this t value? When did it hit 0? And to answer that, when did the height become 0? So we're going to look at our function here of s of t, which is going to be taking negative 1/2, and I'm going to be using the 32 since my problem is working with feet. Negative 1/2 times 32 times t squared. The initial velocity is 100 feet, so 100t plus 10. If I want to simplify this out, I get negative 16t squared plus 100t plus 10. Now, this is not a problem that can be factored out, so I'm kind of out of luck there. But as far as solving this goes, again, I'm trying to figure out what is my domain. So how long was that projectile in the air? So I need to figure out, well, how long did it take until it hit the ground? That would be referring to when our height is 0. So I'm going to go ahead and take my quadratic here and set it to 0. Now, using our quadratic formula, we could go ahead and solve for t. So I can take negative 100 plus or minus the square root of 100 squared minus 4 times negative 16 times 10. And this would be all over 2 times negative 16. Simplifying this out here, I'm going to get negative 100 plus or minus the square root of 10,640 all over negative 32. Now, if I go ahead and I put this into my calculator, I'm going to get two answers for t. I'm going to get t is approximately negative 0.098, or I'm going to get that t is approximately 6.348. Well, now if I look at these two answers and where are they? I have a negative answer for time and I have a positive answer for time. Well, the positive one makes sense here. So this is saying that it took 6.348 seconds for that projectile to be launched and for it to hit the ground. So right there, that is answering our domain question for this problem. Our domain, we're referring to the amount of time, and time is going to be the values that are between 0 and 6.348. That's the amount of time that the projectile was in the air for. Now you might be thinking, well, what's this other number doing? Well, if I was to continue with this graph here, this graph here is a picture of what it would be in this situation. But if I just look at this equation, quadratics have possibly two solutions. And so here is where my two solutions are. All right, so we found the domain. Now we need to take a look at, well, what is the range of this problem? Range is referring to our y-axis here. How far, what values of it can y possibly be? Well, with this projectile being shot up in the air and it's going to hit the ground, it's not going to penetrate into the ground. And so here we're looking at our range has to be some value that's greater than or equal to 0. But what is that maximum height that it gets to? That's what we got to start asking ourselves. And that maximum height right here, that is our vertex. Now, some of you might know the formula for finding the vertex, but you can get away with solving this without knowing that formula too, because that vertex is based off of your axis of symmetry. And that's a parabola. Parabola has symmetry. It's the same on both sides. So right here, this point is going to be the midpoint of our two zeros that we have here. So finding the midpoint, if you recall that from geometry, you can take the two numbers, add them together, and divide them by 2. So I'm going to go ahead, I'm going to take negative 0.098. I'm going to add 6.348 to that, and I'm going to divide that by 2. And here I end up getting, I got to make sure, 3.125. So what that means here is it's at 3.125 seconds, this projectile is halfway, it's at its maximum point. Now you have to be careful that you're not doing the midpoint of 0 and 6.34, because that 0 right here is not where, that's not where the symmetry is. The symmetry is from that negative 0.098. All right, so we know that at 3.125 seconds, the projectile was at its maximum height. So now, what is that actual height? Well, use that answer right there and put it back into your function. Figure out what the height is. Take s of 3.125. So we're going to take the negative 16 times 3.125 squared, add it to 100 times 3.125, and add 10 to that. In your calculations then here, you should end up with 166.25. And so this maximum height that we are reaching now is 166.25. And so as far as our range, and I know that this is really messy, so I apologize. So our range that we're looking for is talking about the values between 0, and this would be s of t that we're referring to, and it has to be less than 166.25. Now, yes, you could also use negative b over 2a to help you find your axis of symmetry, and that would help you find that 3.125, and then plug that back in to find your vertex as well. So this video right here is just kind of a friendly little reminder of what quadratics are all about, and trying to also relate it to some of the stuff that we're talking about earlier in the chapter. In your assignment, I'll have you guys practicing a few problems and definitely looking at some of these vertical motion problems and helping you identify that domain and range. If you have questions, please feel free to jot them down. If you need to send me any emails or anything, also feel free to do that.